National Electrical Code Section 620.37 prohibits the installation of receptacles in the hoistway or pit at elevators, escalators, dumbwaiters, or moving walkways. However, there is an exception to this rule. The exception states that if the interior of the hoistway is drywalled or its equivalent, then receptacles are permitted. Therefore, the application of drywall or an equivalent material to the interior surfaces of the elevator shaft would allow for the compliant installation of receptacles and associated wiring on the back wall of the shaft. It is important to understand the reasoning behind this code. Firstly, elevator shafts are considered potentially hazardous environments. Secondly, they are subject to specific safety regulations. Thirdly, the presence of exposed electrical equipment, such as receptacles, increases the risk of electrical shock or ignition of combustible materials. Fourthly, the code aims to minimize these risks by restricting electrical installations within the shaft. Fifthly, the exception for drywalled hoistways recognizes that a continuous, non-conductive barrier, such as drywall, significantly reduces the likelihood of electrical hazards. Sixthly, drywall provides a degree of physical protection to the wiring. Seventhly, it prevents accidental contact with energized components. Eighthly, it also limits the spread of fire. Ninthly, the term or its equivalent allows for the use of other materials that provide similar fire-resistant and insulating properties to drywall. Tenthly, such equivalent material should be carefully evaluated. 11thly, they need to ensure that they meet the same safety standards as drywall. 12thly, before making any electrical installations in an elevator shaft, always consult the most recent version of the National Electrical Code. 13thly, it is crucial to adhere to all applicable local codes and regulations. 14thly, it is also important to consult with a qualified electrical inspector. 15thly, to ensure the safety and compliance of the installation. When applying drywall to the interior of an elevator shaft, several factors must be considered. Firstly, the drywall should be securely fastened to the walls of the shaft. Secondly, all seams and joints should be properly sealed to maintain a continuous barrier. Thirdly, any penetrations through the drywall for wiring or other equipment should be sealed to prevent the passage of smoke or fire. Fourthly, the type of drywall used should be appropriate for the environment. Fifthly, fire-rated drywall may be required in some jurisdictions. Sixthly, the installation should not obstruct the operation of the elevator or interfere with any safety devices. Seventhly, the National Electrical Code provides detailed requirements for electrical installations in elevator shafts, covering various aspects such as wiring methods, grounding, and overcurrent protection. Eighthly, it is essential to follow these requirements carefully to ensure a safe and reliable electrical system. Ninthly, the code also addresses the installation of lighting fixtures in elevator shafts. Tenthly, it specifies the types of fixtures that are permitted and the requirements for their installation. 11thly, lighting fixtures should be protected from physical damage. 12thly, they need to be positioned to provide adequate illumination for maintenance and inspection purposes. 13thly, in addition to the National Electrical Code, other standards and regulations may apply to elevator electrical systems, such as those issued by the American Society of Mechanical Engineers (ASME). 14thly, it is important to be aware of these standards and to comply with them as well. 15thly, proper grounding is essential for the safety of electrical systems in elevator shafts. 16thly, the grounding system should be designed to minimize the risk of electrical shock and to provide a path for fault currents to flow back to the source. 17thly, all metal parts of the elevator and its electrical equipment should be properly grounded. 18thly, regular inspections and maintenance are crucial for ensuring the continued safety and reliability of elevator electrical systems. 19thly, inspection should be performed by qualified personnel. 20thly, they need to identify any potential hazards or code violations. 21stly, any necessary repairs or corrections should be made promptly. 22ndly, it is also important to keep the elevator shaft clean and free of debris. 23rdly, to prevent fire hazards and to ensure the safe operation of the elevator. In summary, while the National Electrical Code generally prohibits the installation of receptacles in elevator shafts, an exception is made when the interior of the hoistway is drywalled or its equivalent. This exception recognizes that drywall provides a degree of protection against electrical hazards. However, it is crucial to follow all applicable codes and regulations. The goal is to ensure that the installation is safe and compliant. Always consult with a qualified electrical inspector before making any electrical installations in an elevator shaft. Proper planning, installation, and maintenance are essential for ensuring the safety and reliability of elevator electrical systems. The National Electrical Code Section 620 covers elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. Part 3 of 620 specifically addresses wiring. 620.21 covers wiring methods. Machine room and machinery space wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit where flexibility is necessary, liquid-tight flexible metal conduit, and liquid-tight flexible non-metallic conduit. Cables used in machine rooms and machinery spaces must be installed in raceways. Hoistway wiring methods include rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. Cables used in hoistways must be installed in raceways. Flexible metal conduit or liquid-tight flexible metal conduit is permitted between the disconnecting means and the hoistway wiring. 620.22 covers branch circuits. A single branch circuit must supply the car lights, receptacle, ventilation, heating, and air conditioning. A separate branch circuit is required for lighting and receptacles in machine rooms, machinery spaces, and pits. 620.23 covers overcurrent protection. Each branch circuit must have overcurrent protection as required by the National Electrical Code. 620.24 covers disconnecting means. A disconnecting means must be provided for each elevator, dumbwaiter, escalator, moving walk, wheelchair lift, and stairway chair lift. The disconnecting means must be located within sight of the motor controller. The disconnecting means must also disconnect all ungrounded conductors. 620.37, as we discussed earlier, covers receptacles in hoistways and pits. Receptacles are prohibited in the hoistway or pit unless the interior of the hoistway is drywalled or its equivalent. This exception allows for receptacles to be installed for maintenance purposes. 620.51 covers supply equipment. Motor generator sets and machine room control and brake resistors must have overcurrent protection and disconnecting means. 620.52 covers location and guarding. Control panels and disconnecting means must be located in a readily accessible location. They must be guarded against accidental contact. 620.53 covers grounding. All metal parts of the elevator, dumbwaiter, escalator, moving walk, wheelchair lift, and stairway chair lift must be grounded. The grounding conductor must be sized in accordance with the National Electrical Code. In addition to the specific requirements in Article 620, other articles in the National Electrical Code may also apply to elevator electrical systems. For example, Article 300 covers wiring methods. Article 250 covers grounding and bonding. Article 430 covers motors, motor circuits, and controllers. It is important to consult all applicable articles in the National Electrical Code to ensure that the electrical system is installed in accordance with the code. The exception to 620.37 recognizes that drywall provides a degree of fire resistance and physical protection to the wiring. The code allows for receptacles to be installed for maintenance purposes. Drywall must be installed properly to provide the required protection. All seams and joints must be properly sealed. Any penetrations through the drywall must be sealed. The type of drywall used must be appropriate for the environment. The installation must not obstruct the operation of the elevator or interfere with any safety devices. Proper grounding is essential for the safety of electrical systems in elevator shafts. Regular inspections and maintenance are crucial for ensuring the continued safety and reliability of elevator electrical systems. Inspection should be performed by qualified personnel. Any necessary repairs or corrections should be made promptly. Keep the elevator shaft clean and free of debris to prevent fire hazards and ensure the safe operation of the elevator. Let's consider some of the specific wiring methods that are permitted in elevator hoistways. Rigid metal conduit, or RMC, is a heavy-duty raceway that provides excellent physical protection to the conductors. Intermediate metal conduit, or IMC, is a lighter weight raceway than RMC, but it still provides good physical protection. The electrical metallic tubing, or IMT, is a thin-walled raceway that is suitable for use in dry locations. Flexible metal conduit, or FMC, is a flexible raceway that is used where flexibility is necessary. Liquid-tight flexible metal conduit, or LFMC, is a flexible raceway that is liquid-tight. Liquid-tight flexible non-metallic conduit, or LFNC, is a flexible raceway that is liquid-tight and non-metallic. Cables used in hoistways must be installed in raceways to protect them from physical damage. The type of cable used must be suitable for the environment. For example, if the hoistway is damp or wet, a cable that is rated for wet locations must be used. The branch circuit that supplies the elevator car must be sized to handle the load of the car lights, receptacle, ventilation, heating, and air conditioning. A separate branch circuit is required for lighting and receptacles in machine rooms, machinery spaces, and pits. Each branch circuit must have overcurrent protection as required by the National Electrical Code. A disconnecting means must be provided for each elevator, dumbwaiter, escalator, moving walk, wheelchair lift, and stairway chair lift. The disconnecting means must be located within sight of the motor controller. The disconnecting means must also disconnect all ungrounded conductors. Control panels and disconnecting means must be located in a readily accessible location. They must be guarded against accidental contact. All metal parts of the elevator, dumbwaiter, escalator, moving walk, wheelchair lift, and stairway chair lift must be grounded. The grounding conductor must be sized in accordance with the National Electrical Code. Motor generator sets and machine room control and brake resistors must have overcurrent protection and disconnecting means. When installing receptacles in a drywalled hoistway, it is important to follow the manufacturer's instructions for the installation of the receptacles. The receptacles must be securely mounted to the drywall. The wiring to the receptacles must be properly protected. The receptacles must be GFCI protected if required by the National Electrical Code. It is also important to ensure that the receptacles do not obstruct the operation of the elevator or interfere with any safety devices. Regular inspections and maintenance of elevator electrical systems are essential for ensuring their continued safety and reliability. Inspection should be performed by qualified personnel. Any necessary repairs or corrections should be made promptly. It is also important to keep the elevator shaft clean and free of debris to prevent fire hazards and ensure the safe operation of the elevator. The NEC 2017 edition maintains the same requirements for receptacle installation in elevator hoistways as the 2002 edition. Section 620.37 continues to prohibit receptacles in the hoistway or pit of elevators, escalators, dumbwaiters, or moving walkways, with the same exception for drywalled or equivalent hoistways. This consistency ensures that the safety principles and requirements for elevator electrical systems remain constant across different code cycles. The purpose of this requirement is to minimize potential hazards within the elevator shaft. Firstly, it reduces the risk of electrical shock to personnel who may be working in the hoistway or pit. Secondly, it prevents the introduction of potential ignition sources in an area where flammable materials may be present. Thirdly, the exception for drywalled hoistways recognizes that a continuous, non-conductive barrier can mitigate these risks. Fourthly, drywall provides a physical barrier that protects electrical components from damage and reduces the likelihood of accidental contact. Fifthly, it is important to note that the drywall must be properly installed and maintained to ensure its effectiveness. Sixthly, any gaps or openings in the drywall can compromise its ability to provide adequate protection. Seventhly, the term or its equivalent allows for the use of other materials that provide a similar level of fire resistance and electrical insulation as drywall. Eighthly, these materials must be evaluated to ensure that they meet the same performance standards as drywall. Ninthly, when installing receptacles in a drywalled hoistway, it is essential to follow all applicable code requirements and manufacturer's instructions. Tenthly, the receptacles must be properly grounded and protected by ground fault circuit interrupters or GFCI, if required by the National Electrical Code. 11thly, the wiring to the receptacles must be installed in accordance with the NEC wiring methods, such as rigid metal conduit or electrical metallic tubing. 12thly, the receptacles should be located in a manner that does not interfere with the operation of the elevator or its safety devices. 13thly, the specific requirements for electrical installations in elevator shafts are detailed in Article 620 of the National Electrical Code. 14thly, this article covers a wide range of topics, including wiring methods, overcurrent protection, disconnecting means, and grounding. 15thly, it is crucial for electrical contractors and installers to be familiar with Article 620 and to follow its requirements carefully to ensure the safety and compliance of elevator electrical systems. 16thly, in addition to the National Electrical Code, other standards and regulations may also apply to elevator electrical systems, such as those issued by the American Society of Mechanical Engineers, or SME. 17thly, it is important to be aware of these standards and to comply with them as well. 18thly, regular inspections and maintenance are essential for ensuring the continued safety and reliability of elevator electrical systems. 19thly, inspections should be performed by qualified personnel who are familiar with the National Electrical Code and other applicable standards. 20thly, any deficiencies or code violations that are identified during inspection should be corrected promptly to prevent potential hazards. 21stly, the National Electrical Code is updated every 3 years. 22ndly, it is important to stay up to date on the latest code requirements to ensure that electrical installations are safe and compliant. 23rdly, the National Fire Protection Association, or NFPA, publishes the National Electrical Code. 24thly, it offers a variety of resources to help electrical professionals understand and comply with the code. 25thly, proper grounding is critical for the safety of electrical systems. 26thly, it protects against electrical shock and minimizes the risk of fire. 27thly, all metal parts of the elevator and its electrical equipment must be properly grounded in accordance with the National Electrical Code. 28thly, the grounding conductor must be sized appropriately for the size of the circuit. 29thly, it must be connected to a grounding electrode system that meets the requirements of the NEC. 30thly, the National Electrical Code also addresses the installation of lighting in elevator shafts. 31stly, lighting fixtures must be protected from physical damage. 32ndly, they must be located in a manner that provides adequate illumination for maintenance and inspection purposes. 33rdly, the lighting must also comply with the energy efficiency requirements of the National Electrical Code. 34thly, the use of light-emitting diode, or LED, lighting is becoming increasingly common in elevator shafts due to its energy efficiency and long lifespan. 35thly, LED lighting can help to reduce energy consumption and maintenance costs. 36thly, it can also improve the quality of illumination in the elevator shaft. 37thly, when working on electrical systems in elevator shafts, it is essential to follow all safety precautions to protect against electrical shock and other hazards. 38thly, always de-energize the circuit before working on it. 39thly, use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. 40thly, never work alone. 41stly, be aware of the potential hazards in the elevator shaft, such as moving equipment in confined spaces. 42ndly, follow all lockout/tie-out procedures to prevent accidental energization of the circuit.